5.6 on connecting rate of change, slope, first differences, finding equations, everything. And so here we have a relationship where Ferd is a dog walker. And basically, if you want him to walk your dog, he's going to charge you $50 a month no matter what, plus $2 per walk. It's pretty steep if you ask me, but anyway. So that means no matter what, even if you never walk him, you never call him to walk, he's going to charge you $50 anyway. And then every time he walks, he's going to charge you $2. So we want to use this relationship of Ferd's dog walking business. We want to represent it using numbers, graph, and an equation. So there's 3 ways. The first way, numbers, just means a table of values. Okay, we want to be able to look at just a bunch of numbers that represent this relationship. And you can sort of figure out how it works. It's like if Ferd walks your dog nothing, never, it's going to cost you $50 as long as you're in the club. Okay, if he walks your dog once, you're going to pay the $50 plus $2, right? So $52. If he walks it twice, $54, right? If he walks your dog 3 times, $56, and so on. Okay? So you take the base amount and you add the number per walk, the dollars per walk. Okay? So X is the number of walks, and Y is how much. And again, thinking independent, dependent. You choose the number of walks, and then your price is going to be completely dependent on how many walks it is, not the other way around. That's why I chose that way. So I made a table of values. I made my graph here. This is so represent it using numbers. Done. Okay. Now I just assume 5. Obviously, you could choose. There's nothing in here that says you couldn't choose 0, 2, 4, 6, 8, 12, whatever. You could do it forever. But I just chose 0 to 5. So that's done. And a graph and an equation. So all we have to do with the graph is plot the data points. Okay? Note, I don't know if you remember this in elementary, but because this jumps up, I'm just jumping from 0 to 50, draw a little squiggly to represent a big jump in the graph. But after that, I'm going up by 2s every time. So the graph would start right here at 0 walks is $50. 1 walk is 52, 54, 56. Oh, fantastic. I got off my thing. Sorry, here we go. So all I'm doing here is just plotting these data points. Then I can draw a straight line to represent them. I'll choose one with an arrow on the end because it could go on. You could walk your dog many more times than 5. But really, this is just going to keep going basically forever. Okay? And there's my graph. So now that's done. Now the equation is y equals mx plus b, of course. And you can pretty much, there's a few things you can do. You can calculate m if you want to, but I want to remind you of something we talked about earlier. If x goes up by 1s, then you can just use the first differences, right? So that would be an easier way to find your slope instead of, going rise over run, or you could do it any way though. You could do rise over run, you could do y2 minus y1, it's all the same thing. But I'm going to say since x goes up by 1, then slope equals first difference. Okay? And my first differences then are, well, my first difference is 2. 2, right? And I could keep going, but it's constant. It's a straight line. So m equals 2. So I'm looking for my equation. And to find my equation, I need to know y equals mx plus b is the equation. Right? Well, m is the slope. We got that. Okay? Now b is the value of y where x equals 0. This is my starting point. The value of y where x equals 0, so 50. So my equation is y equals 2x plus 50. So that's 3 ways to represent the same relationship: an equation, a graph, and a set of data. Okay, same idea. Wants us to look at the different ways. So y varies directly with x. What does that tell us, right? When x equals 3, y equals 9. So now we have a data point. So varies directly means that it goes through 0, 0. When it says varies directly, you know it's basically giving you a data point. It's telling you that one data point is 0, 0. Okay? That means also it means that where x equals 0, y equals 0. So my y-intercept is 0. So that's that part. And then to find my slope, I have my 2 data points now, right? I've got 0, 0, which is like my x1, y1, and I've got a data point that it gave me here, right? And that's my x2, y2. So you go ahead and you do the equation, y2 minus y1 over x2 minus x1, sub in the numbers, and you find your slope is 3. So I found the slope in the y-intercept. My equation is y equals 3x plus 0, or just 3x, right? And then graph it. So how we graph it then? My y-intercept is right here. There's different ways you could do it, but I'm just going to say, and I'm going to assume every box jumps up by 1 here, and I'll just take my second data point, 3, 9. So here's my first data point, and I'll take my second data point, 3, and 1, 2, 3, 5, 6, 7, 8, 9. There's my second data point, and I'm going to connect those by a straight line. And again, I can assume that it can go forever. It's probably go forever in either direction. There's nothing that tells me it can't go forever in either direction, so I'll put an arrow on both ends. Okay, so that's my graph. One more question, same idea, but the difference is varies partially. That means it doesn't go through 0, 0. Okay, but it does give me 2 points this time, 0, 6 and 5, negative 8, right? So I have my 2 points. So find the slope and y-intercepts. To find the slope again, use the equation, right? y2 minus y1. So I just say, okay, I'll call this x1, y1, x2, y2, and sub in the numbers. And this time you get a weird slope, minus 14 over 5. That's an odd one and not as fun to use. But notice, by the way, I think what's important to notice is that it's negative, because that's going to change the look of my graph. Okay? And what else, other information do I have? And y-intercept, right. So to find the y-intercept, basically, the y-intercept is the y value where x equals 0. So x equals 0, y equals 6. So it gives me the y-intercept. Okay? So I've got that. Now I can write my equation. Y equals minus 14 over 5x plus 6. Okay? And I want to put, oh, I remember this. I chose a bad grid for this. Let's this is what I have. This looks like my x equals 0, but I want you to cancel that. I'm going to draw another line to represent x equals 0, and that's going to be up here somewhere. Let's choose right here. So pretend that line's not there, okay? Pretend that line's not there, and I'm going to pick this up and make that my x-axis, okay? So let's just right, ignore that line right there. That was a bad grid I did. Okay, so here's my x-axis. So this is x equals 0. That's x equals 0, y equals 0. But we know when x equals 0, y equals 6. So my first data point is going to be from here, 1, 2, 3, 4, 5, 6. So that's my first data point. And my second one is 5 and negative 8. So 1, 2, 3, 4, 5, and go down 8. 1, 2, 3, 4, 5, 6, 7, 8. That's my second data point. So to graph this relation, I take the 2 data points it gave me and connect them by a straight line. That's all you have to do. And again, it can go on forever, so it doesn't have to be right at the points. And it's good. Draw my little arrow at the end to say that this thing could go forever in either direction. And as you can see, negative slope, negative slope. Okay? Okay, that's the last question for this lesson and for this chapter.